Hello, welcome back to part 2 of rules for differentiation. Okay, at the end of this, you should be able to say I can calculate the derivative of a function using the rules of differentiation, and I can interpret the meaning of a derivative. Okay, so let's continue to use our rules of differentiation. Example 10, find dy over dx. That is the derivative. Okay, the derivative takes many different forms, dy over dx. Really, that d means the change in y over the change in x. Okay, so that's the derivative. So we're going to find the derivative of this, and hence find the gradient, aka slope, of the tangent to the function at the point where x equals 2. So, first things first, let's just take the derivative of this thing. So we got y, let's do this, y equals x cubed plus 2x minus, this is x minus 5 over x to the first, so we got to move that x to the first up top and turn it into x to the negative first. Now we can take the derivative. Y prime equals 3x, subtract 1 there, 3x squared plus, there's a 1 there, 1 times 2 is 2, and then we do 1 minus 1, so that's gone. So it's 3x squared minus 2. And then this negative 1 times negative 5 is positive 5. And then we're going to subtract 1 from that x, and it's x to the negative second. Okay? And again, you can leave it like that, or write it as y equals 3x squared plus 2 plus 5 over x squared. Okay? So we've done the first part of this, but now it says, hence find the gradient, find the slope of the tangent to the function at the point where x equals negative 2. So to find the slope of the tangent, and just so you know, when you see these words, gradient of the tangent, this means find the derivative, okay? Whenever you see this word in that sequence of words in there, gradient of the tangent, that means you're going to find the derivative, okay? Because remember, finding the derivative, what we can do is we can plug in any function, any number that we want for x into this derivative function, and it will tell us the slope at that point. Okay, so I know a lot of you are like going, what? It's going to tell us what? Okay, so let me rewind us to a few sections ago. Okay, so remember this chart here back from the derivative function? This was a few sections ago. Remember we went through it on this graph. Let's see if I can pull it up here really quick. There we go. Oops. There we go. So there's the graph. Remember, and we were finding the slopes of all these tangent lines, right? So we figured out that, say, at negative 3, the slope was negative 6, right? So when negative 3, we're at negative 6. And that's where all this data up here is coming in. The slope of the tangent line at when x is negative 3 is negative 6, right? So now here's the great part. Look, if I plug negative 3 into our derivative, because our regular function was our regular function here, we do a different color, is y equals x squared, right? So our y prime, our derivative of this is going to be 2x to the first, right? So if I plug in negative 3 into that, 2 times negative 3 gives me negative 6. 2 times negative 2 gives me negative 4. 2 times 1 gives me 2. 2 times 3 gives me 6. So the derivative will always tell you, you can plug in whatever x value you want, and it's going to tell you what the slope of the tangent line at that given point is. Okay? Okay, so back to this here. So if we want to find the slope of the tangent to the function at the point where x equals negative 2, we're simply going to plug in negative 2 for all of, all of these x's here, right there and right there. That's why I think this is a little bit nicer to then plugging it in with this here. So if we're going to do that, y prime equals 3 times negative 2 squared plus 2 plus 5 over negative 2 squared, right? So this gives us negative 2 times negative 2 is 4 times 3 is 12 plus 2. And then 5 divided by negative 2 squared is 5 over negative 2 times negative 2 is positive 4. So that's 12, 13, 14, 15, and because this 5/4 is 1 1/4, or better yet, let's do this, 1.25. So that's 12, 13, 14, 15.25 is the slope. That's the slope of the line when x equals -2 of this function here. Okay? Okay, just so you can kind of get an idea here. I put this equation here into the graphing calculator, and we graph it, and we get these goofy looking lines here. Okay, so here's -2. So basically what you want to do is go down to where this hits -2, put a point right there, and then this tangent line here. So you can see this is a super steep line, and it happens to be exactly 15.25 is the slope of that line at that tangent point. Okay? Okay. Let's take a look at, another example. Okay, let's move on to example 11 here. If y equals 4x cubed minus 2x, find f prime of x and interpret its meaning. So, there's no x's in the denominator, so we can go straight to the derivative. And so we get y prime equals 3 times 4 is 12x squared. And that is 1 times -2 is -2. Subtract 1 from that, and that's gone. So it's just 12x squared minus 2. Okay? And now interpret its meaning. Big thing right here that you want to remember, like on interpret its meaning, is that this is what we call the instantaneous rate of change. Okay, that's what the derivative formula finds for us. We can find the instantaneous rate of change at any point with this function here. So if we plug in 0, the slope of this line here would be -2. So that would be the instantaneous rate of change. That's the slope at that one point if you just put the tangent up. Okay? Okay. Let's move on here to example 12. At what point on the curve y equals -3x squared plus 2x plus 5 does the tangent have a slope of -10? Okay, so we see that we got tangent and slope in here. So when we see the words tangent and slope, we want to do the derivative of this here. So we got y prime equals 2 times -3 is -6. That's x to the first, right? And this is x to the first right here. 1 times 2 is 2. And then that subtract 1, so that x goes away. And then the derivative of any constant, remember, is 0, because that's officially x to the 0. 0 times anything is going to give us 0, so there's our derivative function. Okay? Now, it says, at what point on the curve of this curve here does the tangent have a slope of -10? So if we plug in a number, it will tell us what the slope is. What they're saying is we know the slope. What's the x value going to be? So what we want to do is -10 is going to go in for this y right here. So we do -10 equals -6x plus 2, and then we just solve here. So we get -12 equals -6x. Divide both sides by -6, and we get that x has to be 2. So we know that on this equation here, if we put in a 2 for the x, the slope is going to be -10 there. Okay? Okay.
Yeah. We should come.
What color was she before?
She's a golden. Was. Anybody want her?
Yes.
Okay. All right, last example here. Example 13, the tangent to f of x equals 0.5 x squared minus ax plus b at the point 6, -4 has a slope of 1. Find a and b. Whew. Okay, so this is where we can get to do a little bit more math rolling on here. Okay, so here's what we want to do for this one here. We got to find both a and b. So what we want to do is we want to try to see if we can eliminate one of those, so we can just come up with the with one of them at a time. So if you think about it, if we take the derivative, this b is going to disappear. That's going to turn into 0, right? So let's do this. F prime of x equals 2 times 0.5 is 1. It's going to be 1x Subtract 1, so that's just 1x, and then this is a 1 here. 1 times negative a is negative a, and then subtract that x, subtract the 1 and the x's go away, right? So the derivative of this function, sorry, that's supposed to, I was trying to make that a little clearer here. So minus a, right? So there's our derivative function, just x minus a. Okay, now we know that the derivative at this point here has a slope of 1, so we can put a 1 in over here, equals 1 times, and we know that the x value here is 6 minus a, right? So 1 equals 6 minus a, subtract 6 from both sides, we get negative 5 equals negative a, so positive a will give us positive 5, so a equals 5, and then we just got to figure out what b equals, okay? Now, what we're going to want to do with this is, now that we know what a is, we only have to find b. We can't find b with the derivative because the b disappears. So we have to go back to the original function here of 0.5 x squared minus a, which we now know is 5. So we'll do 5x plus b, okay? And that's f of x, okay? We know that f of x, that's our y value, so we know if we put negative 4 in here equals 0.5, and we're going to put 6 in for the x, 6 squared minus 5 times 6 plus b. Let's see what we get for this. So negative 4 equals 6 squared is 36, half of 36, 18, minus 5 times 6 is 30, plus b, right? So 18 minus 30 is negative 12, plus b equals negative 4. Add 12 to both sides, and we get 8 equals b. So the b has to equal 8. So this function, not that they're asking for it, but this function, when we substitute everything back in, will actually be f of x equals 0.5 x squared minus 5 x plus 8. And that is the actual function at the point where 6 negative 4 has a slope of 1. Now, it's not asking to you, but you can actually go through and check to see if you get this right, because what we can do is, this is the actual function. So we know if we plug in 6 for x, negative 4 is going to come out for y, right? So negative 4 has to equal 0.5 times 6 squared minus 5 times 6 plus 8, right? Negative 4 equals 6 squared is 36, half of 36 is 18. We did part of this over here. Negative 5 times 6 is negative 30. But then we also have this plus 8, and it's got to equal negative 4, right? So this over here all gives us negative 4 over here. 18 and 8 is 26 minus 30 gives us negative 4, so that part checks out. And then we can also take the derivative of this, f prime of x equals 2 times a half is 1x. We subtract the 1 in there, right? So it's x to the first. And this is x to the first. 1 times negative 5 is negative 5. And subtract 1, the x goes away. Derivative of the constant is 0. So the derivative function is 1x minus 5. Okay. Now, we know that if we plug in 6 for the x, the slope has to be 1. So now we can say 1 has to equal 1 times 6 minus 5. And guess what? We get 1 equals 6 minus 5. 1 equals 1. So those both check out, so we know we have the right answer right there. Okay? All right, that's all there is for the second part of rules for differentiation. If you have any further questions, please feel free to ask. Thanks.